We've got a cyclic quad here. I'm just going to identify it. We're told the two lines here are straight lines, and we're given one angle, the angle DBC, as 60 degrees. We're also told that the blue dotted angle EAB is in the ratio of 2:1 with angle BCD. And we're asked indeed to find the size of BCD. So we need to find this angle here. How do we do it? Well, we've somehow got to use this 60 degrees and move it to other parts of the diagram. So first of all, I can say that because ABC is a straight line, the angle ABD, which is this one here, must equal 180 minus 60, which is equal to 120 degrees. Now, using the rule about a cyclic quadrilateral, we know this angle must be 180 minus 120, which goes back to 60 degrees. I can say brackets, opposite angles in a cyclic quad equal 180 degrees. So we now know that this guy is equal to 60 degrees. So looking at triangle AEC, which is the big one, we know that the blue dot and the green dot must equal 120 degrees. But we also know that the ratio between the blue dot and the green dot is 2:1. So effectively this 120 is split into 3 compartments. And each compartment, that must be equal to 120 divided by 3, which is 40 degrees. So therefore, the green dot, which is angle BCD, must equal 40 degrees because it is one of those angle compartments that comes from the fact that the ratio between them is 2:1. And there you have it.